Hello everyone. Still a few people joining, but we'll make a start. I'll get through this in as good time as we can. I've got my colleague Ellis in the background on the chat, so as we go through, if you've got any questions, feel free to pop them in the chat, and he's there to answer them. This is the first non-residential CPD we've done, and the first time I've used this broadcasting rig, so apologies in advance if it's not as smooth or slick as it could be, but bear with me. So
Can't hear anything.
We'll crack on. So wastewater heat recovery. Who uses it? So it's a cost-effective route to Part L compliance for. It's been largely for house builders and developers since around 2012.
Craig, just so you know, you've gone on to mute for some reason.
Sorry everyone, I think I was muted for a second there for some reason.
Yeah, you're back.
Just to start again, wastewater heat recovery, mainly used for Part L compliance by house builders and developers in the UK since around 2012. For apartments, bungalows, passive house, etc. More recently, and we're seeing a lot of applications and specifications now for non-residential applications, so hence the CPD today. So hotel and student accommodation is one big area we're seeing wastewater heat recovery used a lot as part of a suite of measures for cost-effective building compliance and future operated domestic hot water cost reduction. Also leisure and sports facilities, so traditionally areas with high shower traffic, high shower use environments, so can benefit significantly from domestic hot water cost reduction and potentially domestic hot water plant size reduction as well, and compliance. And much more recently as well, offices so move away from kind of motorised transport towards people cycling, walking to work, that kind of thing. We're seeing showers provided as part of the facilities for offices much more. An area where there wasn't that much significance in terms of domestic hot water costs, but obviously with the application of showers to those kind of environments, that's becoming more of a consideration. And manufacturing, so particularly sort of food, pharmaceutical environments, ever increasing hygiene standards means that showering is becoming a bigger part of their kind of standard hygiene routines. So sterile environments, clean rooms, that kind of thing, showering is being used much more. And why use wastewater heat recovery? So changes to Part L, which came in this year, June of this year, on the 15th of June. So there's 2 new approved documents. Part L's been slimmed down from 4 into the 2 volumes. So volume 1 for dwellings and volume 2 for buildings other than dwellings, so non-residential, which is what we're focusing on. They're an interim step towards the future home standard and future building standards that will arrive in 2025. Non-domestic buildings will now be required to meet target primary energy rate. So the primary energy is either from renewable or non-renewable sources that has not undergone any conversion. It takes into account any upstream processes used to produce that energy. And significantly there are higher performance targets, so CO2 emissions reduced by 31% for dwellings, but 27% for other buildings, so non-residential. And we've seen obviously a big uplift in wastewater heat recovery use because of that, and wastewater heat recovery specification, and that's across the UK. But in London, there's been a real focus because of London Plan and the additional uplift that's required for that. We've seen a lot of focus, particularly in London, for our products. The B lean part of the London Plan, so the demand reduction. Particularly, it looks for a 15% uplift over building regulations, and wastewater heat recovery as a demand reduction technology really helps towards that, makes a significant impact, and actually to the point that in the guidance it's actually quite specific now in saying that wastewater heat recovery should be investigated and set out in the energy assessment. And when you see what impact the amount of energy that goes towards showering on a sort of a typical hotel. You can see why that, why that's the case and why that really makes sense. So why use wastewater heat recovery? So significant energy and CO2 reductions, so very easy to incorporate within a new build scheme. Minimal layout adaptations required to integrate it into the infrastructure. And significant hot water cost reduction. So domestic hot water requirements per shower can be reduced by up to 55%. Less domestic hot water used per shower use, and also is fuel agnostic. So whether you're using gas, electric renewables, or air source heat pumps, whatever it might be, wastewater heat recovery can be used with it. Domestic hot water plant size or cylinder size can often also be reduced. So offers simple, cost-effective Part L compliance. It's one of the cheapest and most cost-effective ways to get compliance. So kind of on a points per pound basis in SAP and SBEM, it's very, very effective and very competitive. Simple compared to most alternative measures. So in terms of designing it in, it doesn't have an impact on other measures or other technologies very much at all. And Recoup can help with specification and design in from that point of view. And it's fit and forget. So unlike other technologies, it's once it's installed, there are no user controls, there's no on-off switches, there's no interaction required from end users at all. Once it's installed, it's just there and it works. So it's completely passive, and most users don't even know they have wastewater heat recovery in place. So there's no impact on their sort of showering experience or anything. No planned maintenance at all. So other than one of our products, there's no electrical connections or moving parts, filters or consumables. So no sort of maintenance schedule or planned maintenance at all. Things like normal drain cleaners can be used and that kind of thing, but there's no additional maintenance or planned maintenance required over and above when wastewater heat recovery isn't present. And has a long working lifespan. So bays, or what were bays, have published lifespan of 40 to 60 years for the vertical pipe systems. So in line with the plumbing infrastructure generally, kind of like 20 years for the horizontal systems. So compared to sort of other technologies, the lifespan is quite significant. And they have a very low embodied carbon. So we have a cradle-to-cradle manufacturing process, and we'll look at the embodied carbon in a slide a bit later. They're SAP, SBEM, BREEAM, PHPP and RAS certified. So if you're looking for BREEAM points, you can use them towards credits for BREEAM. But any of those certifications you need, we can provide. I will say before we start looking at any products today that we're going to be looking at instantaneous localized wastewater heat recovery products. So these are products which are localized to the showers they're connected to. So maybe one or two showers connected to each wastewater heat recovery unit. So they're all very high efficiency. There's low system losses. They're all passive, so there's no mechanical, electrical components or parts in them, or no planned maintenance. That's in contrast to maybe a plant-sized or a centralised system for wastewater heat recovery. They're not something we offer at the moment. They are available, not particularly widely in the UK at the moment. We are potentially looking at bringing those into the UK and becoming a distributor for a plant or centralised wastewater heat recovery unit. So if that's something you're interested in, it'd be good to get some feedback and whether you have applications for those. At the moment, we don't have them available. So as I say, today we'll be looking at the localised sort of instantaneous wastewater heat recovery products. But yeah, any insight you can give on those, on sort of centralised systems, which we might be bringing into the UK, then that would be good to know. So how does it work? So wastewater heat recovery is a simple heat exchanger technology. So we take the warm shower waste, we use the heat from that and transfer it into the incoming cold mains. So shower hot wastewater enters one side of the wastewater heat recovery heat exchanger. The mains cold water simultaneously enters the other side of the heat exchanger, and the heat energy from the shower, hot wastewater, is transferred via the heat exchanger into the incoming mains cold. So there's no storage or harvesting of grey water or anything like that. It's purely an instantaneous heat exchange, and that preheated water we're producing is used instantaneous. It's not stored or saved. It's an instantaneous heat exchange, and we use that preheated water. So yeah, the now cool shower water wastewater exits the wastewater heat recovery to the waste, and the preheated water can be used in one of three ways. So it's just a simple heat exchange technology. The three different ways that the preheated water can be used are known as system A, B and C, and essentially there are three different ways that the products can be installed. So it doesn't matter which wastewater heat recovery product it is you're looking at. System A, B or C all apply, and you can install it in one of those three ways. So firstly, system A. System A is the most efficient installation method, so it's always kind of first option if it can be accommodated. What system A means is that preheated water, it runs through comes from the wastewater heat recovery unit, and it then gets sent to the cold side of the shower's thermostatic mixer valve and also to the water heater. So you're taking that preheated water that you produce at the wastewater heat recovery unit and sending it to two places. So when you send it to the shower head, you get a hot water saving there, because the thermostatic mixer valve will change the ratio between the hot and cold to use more pre-issued or preheated cold water and less hot. So normally when you don't have wastewater heat recovery present, you'll have a shower head temperature of around 40-41 degrees, and that's made up from about 70% hot water, 30% cold, so maybe 55-60 degrees hot water, 10 degrees cold water coming in. 70% of that will be hot, 30% cold, and you'll get a 40-degree shower temperature. When you have wastewater heat recovery present, because that cold water is now preheated and is maybe coming in at 25, 26, maybe 28 degrees even, the thermostatic mixer valve will change the ratios between the hot and the cold. And you'll now start using maybe close to 70% of the preheated cold water and maybe only 30% cold. So you're instantly using less hot water per shower. And then with system A, you're also sending preheated water to your water heater. So you're using less hot water at the shower head, but then the preheated water that's going to your water heater means you're now only heating your hot water from 25 degrees to say 55 instead of from maybe 10 degrees to 55. So the hot water you are using is using less energy to produce it. So you get like a double whammy with system A. You get less hot water usage at the shower, and the hot water you are using is produced with less energy. So system A is the most efficient installation method. I'll say at this point that wastewater heat recovery at the moment is recognised for use with thermostatic mixer showers only. So the thermostatic mixer valve can regulate the temperature and flow to keep a fixed temperature at a constant flow. Most electric showers on the market won't do that at the moment. So wastewater heat recovery at the moment is purely for thermostatic mixer showers. That may change. I'm pretty sure it will change at some point, but right now we're looking at thermostatic mixer valve showers only with wastewater heat recovery. So system A is the most efficient method. It's ideal where you've got the hot water supply, so your hot water plant, maybe the cylinder, gas boiler, HRU, whatever it might be, relatively close to the shower. So that run of pipe work from the wastewater heat recovery unit to the heat source isn't too far. It's not appropriate for where you've got centralised hot water though. So if you imagine you've got a hot water plant or a centralised hot water system, you can't be sending all of your hot water through multiple wastewater heat recovery units back to your hot water plant. So anywhere you've got centralised hot water, which can be the case in quite a lot of non-residential projects such as hotels and that kind of thing, you then have to look at system B. So system B installation essentially means you send that preheated water only to the showers. So that way it's purely on the cold side, isolated from your hot water side altogether. So that preheated water goes to the shower head, to the shower mixer valve, and that ratio changes and you get a pure domestic hot water use reduction. And system B is not quite as efficient as system A. It's a little bit less efficient, but where you've got like a centralised hot water plant, it's really the only option. and it still offers really significant savings, which we'll have a look at in a second. Lastly, System C, don't see it very much in non-residential applications, used in some kind of specific residential applications sometimes, but it's not specified that much. For the purposes of non-resi and localised sort of wastewater heat recovery, you probably wouldn't specify it much at all, but essentially it just means you send that preheated water to your hot water source only and not to the cold side of the shower, so you're just sending it back to your hot water source. Just to summarise that, you've got System A, preheated water supplied to the shower and the water heater. System B, preheated water supplied to the shower only. And System C, preheated water supplied to the water heater only. So what does that actually look like? So System A, so this is based on our Pipex, which is the most efficient product we do. It's the vertical pipe system. You're looking at System A efficiency at 11 litres per minute of just over 63%, and 9 litres per minute, just over 68%. Like any heat exchanger, the slower the flow rate through it, the more efficient it gets. So as you go down the flow rates, you get a higher efficiency. So you can see on the right-hand side there, the PCDB listing, the product characteristics database listing for the different efficiencies at different flow rates. You can see as it goes down, it gets more efficient. If you look at System B in comparison for the same product, you see it drops a little bit. So you drop into sort of 52% efficiency roughly. So you can see you go back to System A, it kind of drops by 10-12% maybe over System A installation. So System B is that a little bit less efficient. Obviously, let's say for centralised, where you've got centralised hot water, for example, it's really your only option. It still offers really significant savings. So you've got hot water demand reduction there of sort of 44% at 11 litres per minute, 47% at 9, and obviously getting higher with a lower flow rate. So it's still a really significant saving with the System B installation. Just to recap, installation time, a couple of hours maybe for most systems. Obviously it does depend on the particular product and scenario, but generally a couple of hours for install is sufficient. You need basic plumbing materials and tools required, so there's no specialist training or commissioning at all, and no planned maintenance, so just simple routine cleaning. You can use standard drain cleaners, domestic drain cleaners and that kind of thing, and they can be rodded, no problem if necessary or required. And no behaviour changes, so it just works automatically every time you shower. No user controls or able to be switched off or anything like that. So we'll look at some of the products now. I mentioned the Pipex already because it's the most specified product we have. It's the most efficient and cost-effective product we have. It's a vertical pipe system. So it stores on the floor below the shower it's connected to. That's one important thing. So it's a 2 metre vertical pipe. The image here is taken from a sort of more residential setting, but it's nice just because you can see the shower tray above and how that would feed down into the top of the Pipex below. So it's installed on the floor below the shower that it's connected to. So sort of for first floor and above showers, it's great. It's very high efficiency. So you can see the efficiency figures there again. We gain that efficiency by the use of our turbo rotator. So the turbo rotator is the device you can see on the top there where the shower waste connects into. It works by spinning the water in a cyclonic motion down the centre of the pipe. That means the water clings to the inside of the heat exchanger pipe. You get that thin film heat exchange through the heat exchanger, and that's what gives us our high efficiencies. And you can see, yep, this is working. A little video here that shows that. So you can see the water flowing round and the turbo rotator spinning the water through the pipe. Obviously, there's normally be a copper heat exchanger, but we've swapped that out for a transparent piece of plastic pipe on this video, just so you can see how it works. But that's what gives us that high efficiency. We get the maximum contact with the inside of that heat exchanger pipe. It's a simple first fix installation. Let's say 1 to 2 hours, typically, solvent well connections, and the cold feed and the preheat out feed are 1/2 inch male BSP connections. We don't supply the irons for those, you need to supply those. You also just need a couple of full flow isolator valves or full bore isolator valves and a double check valve. One quite important thing to note with our products is that we have double walled heat exchangers on all of them. So what that means effectively is that we comply directly with the UK water regulations. There are products, or have been products on the market which don't have that, and there are some implications which, if they don't, you have to consider. So that if you don't have a double walled heat exchanger to comply, then that does mean you have to move your shower trap downstream of the wastewater heat recovery unit. That will mean probably increased installation height. You could get falling water noises and that kind of thing. So we have a double walled heat exchanger. It means we directly comply, so there's no modifications or changes needed to the sort of the showering trap or anything at all. You might be able to see on the image there as well, there's some like small holes or striations around the top of the copper pipe. That's our leak detection system. So they run the whole length of the heat exchanger. So if there was ever a perforation or anything penetrated the heat exchanger and water was to try and leak through, we'd get visible leak detection at the bottom of the pipe. So it would mean we've got a visible leak detection system, and again that means we comply with the water regulations directly. In practice we've never actually had one which has leaked that way at all. They're all pressure tested when manufactured at the factory, so we're confident they leave the factory without that being a problem, but it's there as a kind of belts and braces method to water regulations compliance. But it's just worth noting is not every single product on the market has that double walled heat exchanger. So in reality, what does that look like? So just a quick case study of a project that used the Pipex here. So redevelopment of Camden Town Hall into a 270 bed hotel. It's designed to achieve a BREEAM status of very good. So as I said before, you can get your BREEAM credits with wastewater heat recovery. And one of the first UK hotels to install wastewater heat recovery. It was an ARUP design, so an ARUP M&E design, and they utilised the Pipex in a 2-to-1 configuration. So they've got 2 showers feeding into one Pipex. Obviously that makes it much more cost effective and improves the ROI. So you can see there you've got 2 showers back to back, so quite a common kind of setup maybe in a hotel or something like that, where you've got a service riser centrally. So the 2 showers the wastes feed into each other and then into the top of the turbo rotator on the Pipex. Waste flows down and out of the bottom into the soil stack, and then in the bottom of the Pipex you've got the cold feed coming out the top preheated, coming out, and then teeing off to the 2 showers, to the TMVs on the 2 showers. So that's become quite a common application or a blueprint for the way we see wastewater heat recovery integrated into a lot of sort of hotel projects. Is this kind of configuration. You obviously don't have to do 2 into 1. If the shower arrangement isn't appropriate, you can certainly still just do 1 into 1. But if you can get the 2 into 1, then it just means that project's that much more cost effective and the ROI is that much better. So on that particular project, the domestic hot water demand for the showering has been reduced by about 42%, and that's been in operation since roughly 2019. ARUP actually on that, if you want to do some reading, wrote a white paper on transforming existing hotels to net zero carbon, where they concluded that they strongly recommend wastewater heat recovery for new hotels or major refurbishments. Similarly to the 2-to-1 on the same floor, you can stack showers above each other into one wastewater heat recovery unit. So we've got an example of showers on different floors. So the waste from the one coming down into the other and into the top of the Pipex, and then the preheat from the Pipex being fed up to the 2 showers above. Obviously you need to take into consideration with any specification in the sort of the flow rates and pipe runs, and obviously where you start adding multiple showers to one wastewater heat recovery unit, it becomes probably more of a consideration. So the Pipex on the system B, you're looking at a sort of combined total flow rate of up to about 24 litres per minute. So standard sort of shower flow rates, that's not really an issue at all. you do need to stay within the maximum pipe runs, so the pipe run length from the wastewater heat recovery unit to the cold side of the shower TMV should be no longer than 4.75 metres in 15mm copper. That's a requirement to maintain the lowest possible risk Legionella compliance. So I'll talk about Legionella because it's something that gets asked about quite a bit with wastewater heat recovery. So all of the products we have and all of the system types, so system A, B and C installation, are all independently Legionella control risk assessed. So we've had them all independently tested. They're all deemed lowest possible risk, so there's no zero risk with Legionella. There's lowest possible risk as low as you can get, and as long as they're installed according to our recommendations, then we maintain that lowest possible risk compliance. There are some things you need to stay within to do that. So that distance of 4.75 metres, that's one of the elements you need to look for to stay within that. And also around the waste recovery unit not being in areas of high ambient heat or being insulated, for example. But yeah, if you stay within that 4.75 metres, then you'll be within the compliance for that Legionella risk assessment. The normal Pipex is for 99% of applications for the hotel, student accommodation, that kind of thing is going to be absolutely fine in terms of your maximum flow rates. We have had a couple of projects recently where the flow rates that have been specified have been very, very high. So we're talking maybe sort of 40, 50 plus litres per minute. Although we've had the regular Pipex, we've had tested kind of 30, 35 litres per minute. There may be projects where you've got these very, very high flow rates, and in that case we do have other products we can look at, sort of high flow variants. I say they are quite niche. The regular Pipex is probably still going to be the most appropriate product most of the time. We do also have options where maybe you're limited on space, so we have shorter variants of the Pipex. So we can do the Pipex RD, which is a slightly shorter version, and then we can also do bespoke lengths as well. So if you do have sort of space limitations and that kind of thing, we can look at options for you as well. Best thing is just to contact us, and we can advise on the most appropriate sort of pipe product. So the Pipex is, I say, the most sort of the go-to product really, if possible. There are situations where it's not appropriate. So as I said, it's gravity fed, so it needs to be on the floor below the shower that it's connected to. So where you've got ground floors or where you can't accommodate the pipe on the floor below, we have the Easy Fit, which is a horizontal wastewater heat recovery system. Not quite as efficient as the vertical. Being horizontal has just not quite got the same efficiency, but still significant, so you can still sort of see up to 47% efficient there. It's designed to fit primarily under a bath, so where you've got showers over baths, it's ideal. So designed to fit under that in that sort of void space below the bath, which is usually spare. So great for hotels, student accommodation, retrofit, or ground floor showers. And it will also fit under sort of suitably sized riser shower trays. So I think about a 1400 tray roughly required to accommodate it with about 110 mil height clearance approximately. So under sort of larger riser shower trays, it will certainly fit. But yeah, designed primarily for under baths. It's very simple to install. So it works in exactly the same way as the Pipex, with the warm shower, wastewater entering one end, exiting the other, and the counterflow heat exchange with the cold mains water coming in the other end, and then exiting preheated. It's quite flexible, so depending on whether which end your shower waste is in relation to your soil, you can pipe it so that it can be used either way. It's designed so that adding that extra run of pipe work doesn't increase the overall height too much. Similar to the Pipex, pair of isolating valves, double check valve again required. You can see, or maybe just about make out on here, that the kind of the profile of the Easy Fit is shaped so that you've got somewhere to run that length of waste pipe from if you need to orientate it that way. And there's obviously no planned maintenance again on these like the Pipex, so it's designed not to block or become trapped. To date, we've not had any blockages on these, but again, you can use regular drain cleaners or rod them if you wanted to. But under a bath or under a shower tray, we'd consider them reasonably accessible anyway. But yeah, no planned maintenance on these at all. If you do have a bath with a central leg, Obviously that would be in the way of the EasyFit where you normally accommodate it, so you might need to brace the bath out. There are leg sets available for being able to do that with, so some from Rocker, for example, we've got on the screen there. They give plenty of space to accommodate the EasyFit. So if you do have a central leg bath which needs to be removed, you can get these leg sets to accommodate the EasyFit. Just another quick little case study. So this is Max Forden project, so student accommodation. It's had a mixture of the Pipex and the EasyFit used on it. So on the first floor, they were using the Pipex, so they could put the Pipex on the ground floor to service the showers on the first floor above. And then for the ground floor showers, obviously couldn't use the Pipex because they were on the ground floor, so then they've used the EasyFit. What's interesting about this one is, although I said the waste heat recovery is not currently recognised for use with electric showers, on this they did use electric water heaters, so they still had TMV showers, but used an instantaneous electric water heaters for their hot water supply, and that worked really well with the wastewater heat recovery. So as I said, they had they had service risers and bathroom pods on there. So for the first floor showers, they could use service risers, so 2 showers into 1 Pipex on the floor below, similar to what we looked at for the other case study. And then on the ground floor is where they used the EasyFit. So they had bathroom pods for the ground floor manufactured to accommodate the EasyFit within. And so it's a nice case study using both of those products. It's a continually monitored project. So it's been continuously monitored for a while. The interesting thing is that one of the interesting things with it is that the hot water use is actually higher than predicted. That's actually been attributed to the fact that the Pacify software, so the PHPP software, assumes a 5-minute shower duration. In actual fact, in reality, it seems that students take longer to shower than that, so about 7 to 8 minutes. So their domestic hot water use has actually increased. I think that's quite a common thing we see in terms of modelling, that actually hot water use or shower uses probably exceeds what's quite often expected, which obviously means waste heat recovery then obviously has even more of an impact. So that's the Pipex and the EasyFit. We also have the drain range. The drain range is a wet room type floor gully with an integrated wastewater heat recovery. So see it used in a lot of kind of gyms, leisure centres, those kind of environments where you have banks of showers. As you just see some images there, so as I say, anywhere you've got banks of showers, high shower traffic environments is ideal with a tiled floor. Very efficient, so say up to sort of 57% efficiency based on the model. You can see the top of one of the drains there open, so you've got a stainless steel percolation plate where the flow of shower wastewater is directed through. That directs it to fall onto the copper coiled heat exchanger below to give that high efficiency. As I say, ideal for commercial sort of leisure environments, so gyms, leisure centres, that kind of thing. Can also be used in residential projects as well, so wet rooms, tiled wet room floors, etc. The other thing you can see on there is the 2 different types of cover plate we have. So there's a stainless steel cover plate and a tiled cover plate. You've got 2 choices of finish. The tiled one's quite nice because if there's a slip rating for the floor, then you can maintain that slip rating with the tiled cover plate. As I say, with high traffic areas that you do get in gyms and leisure centres, they're really effective. So common ROI on those maybe 2 to 6 years. One gym box example we've got there, which has been in place for a few years now. The ROI on that was just over a year with the high shower traffic that they had. We've got a few different models. A couple of these are the Drain Plus Duo and the Drain Plus Duo HE. The HE obviously being the more efficient model. It is that much deeper than the Drain Plus Duo, so depending on your floor structure and makeup might dictate which way you go with those. The Drain Plus Duo is that much shallower, but essentially both work in the same way. The HE has a double sort of layer heat exchanger, so it has two separate heat exchanger coils inside to get that extra efficiency from it. The HE version is what you can see here. So you can see very high efficiency, and again you can see the stainless steel cover plate. You also see the tiled cover plate. Works exactly the same way again as the previous product. So the cold feed comes in, comes out preheated. The shower waste goes in the top of the drain and comes out of the waste connection at the siphon there. So you can see again here, a pair of isolator valves and a double check valve. On this image they're pictured quite close to the drain here. In reality I don't think they normally get installed that close. They can be sited a little bit further away where it's maybe more appropriate or accessible. In reality they don't need to be accessed. As I say, the only time they're really going to be used is really for replacements of the unit, so it's not like they need to be used on a regular basis, but probably not practical to have them that close to the drain unit. They quite often say located somewhere a bit further away that's a bit more accessible. And you can see the siphon, the waste siphon coming out to the side of the unit there. The waste is rotatable, so it's got a 360-degree horizontal waste there. So you can see on this image from above, you can see the waste coming out of the end, as opposed to on this one where it's coming out of the side. So you can orientate it depending on where you want to take your waste to. So you've got quite a bit of flexibility in terms of the installation. And we also have a vertical waste kit for it as well. So as standard they come with the horizontal, but you can have the vertical if you want to specify that, so you can take it straight into your soil stack. So I mentioned Gymbox previously, so it's somewhere that's been in place for a little while now. They had 20 male, 19 female showers, and they opted to go for 2 showers to 1 drain. So effectively the drains kind of straddled the shower cubicles. So again, makes it much more cost effective if you can get 2 showers into 1 drain. And obviously installed a System B because it was a centralised hot water plant. You can see on this one a little bit more clearly, you can see the shower cubicles, and then each 2 shower cubicles serviced by one floor drain. As I said, System B installation because it was a centralised hot water plant. And in comparison, 2 into 1 drain isn't really that different at all from installing 1 to 1. Just means when that preheat leaves the drain unit, you're then going to tee it off to the 2 showers. So it's really quite straightforward. As I mentioned, the savings on that were really quite significant, with an ROI of just over a year, which is pretty amazing, really. But we can do these kind of calculations for you, so we have the calculator. So if you have projects like this and you have the data that will expect predictions for shower usage or hot water usage, then we're happy to do these sort of calculations and put together predicted savings for you. I'll bring this on finally to the Recoup Pipex Active. So the Active is a more recent addition to our product portfolio. It differs slightly from the other products in that it's an active system, so it has a pump, whereas all our other products are kind of passive, gravity-fed, fit and forget products. The Active does bring in an electrical sort of mechanical element, but it's ideal for ground floors where you can't necessarily use the vertical system, the Pipex, the standard Pipex vertical system, or where you can't accommodate maybe the easy fit horizontal system. So there is a place for it. We've seen a lot of specifications for some MOD projects recently, so it does fill a gap for wastewater heat recovery where it was needed. It has all the benefits and the high efficiency of the gravity-fed vertical Pipex. So it uses the same vertical heat exchanger. The difference being it's now a pump system. It's quite adaptable in how you install it. So there's, in terms of the positioning of the pump in relation to the shower and the wastewater heat recovery unit, you've got quite a bit of flexibility. So the pump can be up to a couple of meters from the shower waste. Then you've got another meter or so to play with in terms of positioning to the wastewater heat recovery. So you can position the pump in like a vanity unit or somewhere like that, somewhere it could be accessed, because being a pump, it should be accessible. It's a Saniflow pump, so it's got a long lifespan, very reliable, but still it's an electrical mechanical component, so it should be more accessible and be able to got to in case you needed to. So having an access panel or in a vanity unit, that kind of thing would be ideal. But because I say you've got this flexibility in terms of positioning, you can do that, no problem. We have a buffer vessel on the top of this as opposed to the turbo rotator. So where we have the standard turbo rotator on the top, on the active system we have a buffer vessel, so the pump pumps up to the buffer vessel, fills that, then that allows the water to go down the pipex, and the buffer vessel has like an inbuilt turbo rotator in it. So the active is there if the pipex, the regular pipex or the easy fit or the drains don't fit the build, I see the active as kind of the backup option really. Slight compromise, as I say, in terms of that electrical mechanical component you're bringing in. You can connect it 2 to 1, similarly to the regular pipex, so in terms of cost efficiencies you can still use that and have 2 showers connected into the one pump, which then feeds the buffer vessel. And it's a really good retrofit solution, so bathroom upgrades, retrofit, that kind of thing. You can just see a little schematic of the breakdown there with the buffer vessel on the top. So the pump runs intermittently, so the pump has a fill level, so once the shower empties it fills the pump reaches that level, it will then pump up to the buffer vessel, and the buffer vessel allows that water shower wastewater to run down the pipex heat exchanger. So the pump only runs about a third of the time that you're showering, so it's not running constantly, so it's a very efficient way of doing it. It's a very low wattage pump. And the efficiencies that you see in sort of SAP and SBEM for it are actually identical to the regular pipex. It's so low wattage and uses so little power, so it's a very high efficient system. Mentioning modelling, we'll just touch on that. So wastewater heat recovery is in SBEM, so it was added in version 5.6a. So you can model it directly into SBEM now. There's the UK NCM Data Wizard showers tab where you can enter the data, so it requires you to enter the number of shower types, it's whether the shower has a heat recovery system or not, so wastewater heat recovery present or not, whether the shower is located over a bath, if the heat recovery is present, a definition of its efficiency, whether the shower is pumped or not, if the shower has a pump, the definition of its pump power, and how many individual showers of that shower type are in the building. So you can directly input wastewater heat recovery into SBEM now. In DSM, you can model wastewater heat recovery via the Apache HVAC tool for IESVE. That is a paid add-on, I believe, so you need to have that package to be able to do it directly. In IES, they refer to wastewater heat recovery as DWHR, so drain water heat recovery. And in there, you have to define the configuration, the number of fixtures and flow rate per fixture, the modulating profile for consumption pattern, the end use temperature, the temperature drop between the end use and the drain side of the DWHR heat exchanger, and the rated effectiveness of the DWHR heat exchanger. So if you've got the Apache HVAC tool for IESV, then that's fine, you can use that and it will go directly in. If you don't, for other DSM modelling, we do know people have used some workarounds to try and incorporate wastewater heat recovery within their models. It's not as straightforward. What we can do for you is supply some project-based calculations. So if you can provide, as I said, with estimates on the shower usage, the showering, and we can then plug them into our calculators and provide some projected savings for you. And you can use them or potentially use them. We know people have for doing things like inputting a domestic hot water energy reduction, an artificial increase of the domestic hot water plant efficiency, or an artificial increase in the incoming cold water mains temperature to reflect the impact that the wastewater heat recovery is having. So if we give you those figures, you can then use them to manipulate things to give you that saving that the wastewater recovery brings. Obviously, it's not as clean and tidy or simple as if you've actually got it built in the software to do it properly, but we have seen people doing it that way. It's somewhere I don't have a direct experience of doing it myself, so I don't use SBEM or any DSM modelling. So it's something that if we can get any feedback on that from anyone who does do it or has attempted to do it, that'd be really useful, because we need to kind of shape our guidance and understanding of this a little bit. This is the information we've had so far in terms of how people have managed it, but any information you could feed back would be really appreciated, either to me or any of my colleagues, and we can then try and improve our understanding and guidance on that a little bit. And we mentioned embodied carbon previously, so just to look at that, Recoup were lucky enough to work with SIBSI in developing the TM65 standard for embodied carbon in residential heating. We use Copper Mark responsibly sourced copper, which is 70% recycled and 100% recyclable. We have a cradle-to-cradle circular model for production. We actually offer a buyback scheme as well for old or transport damaged products, so they can be reused and remanufactured. As I mentioned, the carbon is very low in our products. So looking at the Pipex, you're looking at sort of 59 kilograms of CO2. When you compare that against the potential savings, so against gas, against direct electric, against air source heat pumps, you can see how quickly that is paid back. So it's an incredibly low embodied carbon product. So if that's embodied carbon is a factor in what you're looking at, then you say wastewater heat recovery scores really well in that department. In terms of other resources we have, so we've got our website with document downloads, so all the product information on there, so technical support documents, specifications, instruction manuals, all of that information is on there for download. We've got the YouTube channel. We've got lots of instructional videos and content on there, and previous CPDs for the residential side are on there for download, and the future non-residential ones will be on there too. As I said, CPDs, we've got technical and toolbox virtual meetings as well, so we've got the guys in the technical support team are always there for calls if you need us. And we also have a learning site with product installation courses, so if you've got guys on the tools or on the jobs, then you can get them to come on and do the learning site courses and go through that, and then a little bit more about the installation side of wastewater heat recovery. We've also got a live demonstration installation space, which is where I'm sitting now. So we can, if you're interested in looking in products in more detail, we can literally take a GoPro around and look at the individual products in detail and go over anything specific that you want to look at. We've got the products all set up in our demo room here. That's about it for me. So I don't know if I had any questions in the chat.
No questions as yet, Craig. So no, very good. If anybody does have any questions, feel free to put your mic on and we can attempt to answer them. Just on the subject of the IES and the DSM modelling, if you are essentially an IES customer or a DSM modelling customer, it would be really useful if you could email them and ask for wastewater heat recovery to be included. That essentially they've said they'll add it to their development list if they get enough customer interest. And it just seems a bit crazy at this point that, given that wastewater heat recovery is included in Part L notional dwelling and London Plan, etc., that there isn't a simple method of modelling it in DSM. So if you're able just to send them a couple of lines across just to ask them to add it in, that would be fantastic. Yeah, that would be really helpful. Okay, well, I'm going to stay around for a few minutes. So if anyone wants to talk, you know, one-to-one or anything, I'll hang around for a bit off camera. So yeah, thanks everyone. Appreciate it. Thank you. Just so you know as well, we'll send you a follow-up email with a recording of the presentation, the slides, and some links to knowledge base, etc. So thanks very much, everybody.
Thanks, Al.